So last time, if I had a bunch of data, let's say it starts at 7 and it goes up to 82, right? And I want to make a histogram out of this data so I can present it really nice, quick, descriptive statistics. I can show people what I saw, right? I like what you said, you subtract something from something. To be a little more specific, do you guys remember the example? I can't remember exactly what I did in this room. Oh yeah, that's right. I had drawn something up here, I wanted to panel it. So if I know how long the data goes, and I know how many rectangles I want to use, if I divide how long I gotta go by how many rectangles I want to use, that tells me how wide each rectangle has to be. That should make some physical sense, right? So if I know I want to go from here to you, and I only want to use 6 steps, wouldn't I figure out how far that is and divide by 6 to see how big each step has to be? So a step in this case is just how wide the rectangle is, that's all. You guys with me? So it's a very physical interpretation of that. Okay, all right, maybe. So the class width ended up being the range divided by the number of classes, which was the high minus low divided by number of classes, which, does anyone remember kind of like how many classes we're going to use from what to what? You know, like, dude, that's like last Wednesday, man.
Like the lowest to the highest or something?
Yeah, there's a certain number, anywhere from 5 to 10, but for us, we're going to use 5 or 6 because we're going to have samples that are pretty small. I'm not going to give you 800 data points, right? If I ever do, you're completely allowed just to get up and leave. In real life, you're going to have like possibly thousands of data points, but you're also going to have computer software that can just gobble it up, and you're going to have graduate students that you hire for measly pay that will data entry for you, right? You guys all kind of with me? Okay. Mm-hmm. But in this class, we'll deal with stuff definitely below like 50 data points that you'll have to work with directly. That's plenty. You guys are doing okay. So if I know how far I've got to go, divided by how many classes I want to use, that will tell me how wide each class has to be. So if I know how far I want to go, and to divide that by how many classes I want to use, it will tell me how wide each class has to be. That's it. And the class is literally the rectangles that we see on the picture. How are we doing so far? Does that sound familiar? Yes?
So to find how many classes you need, you just use whatever you want, or whatever you need.
Well, 5 or 6. So in general, we use from 5 to 10. In the real world, in the wild, you could use more or less than that, but 5 to 10 is a good benchmark for how many to use. And again, the larger your sample, the higher the number of classes, but with the size of our samples, 5 or 6 should do for us. Yeah. Okay. So for example, in this one, if I wanted to use 6 classes, let's say, it would be 82 minus 7 divided by 6. What's that?
1?
I think it's 12.5. But I don't know, you guys have calculators, huh? I think it's 12.5. But I could have just gone insane right then. You never know.
12.5.
Okay. Then I would round that to 13. So my class width would be 13. You guys semi with me?
Uh-huh.
Okay. So then,
Round up.
say again?
You always round up.
Always, yes. They have to be at least 12.5 wide to be able to get all the way to the end. So if I round down, they're not going to make it. If I round up, they're going to overcover it. I don't care. I just want every data point to have a place to go. You guys semi with me? Okay. So my classes in this case, I would start at 7. Where would the next class start? Considering our width is 13. No? Our width is 13.
20,
20. So then where should this class up here end?
19,
19. And then the beautiful thing is, you know the width is 13. You just keep adding 13 now. until you get, in this case, 6 classes, right? So I'd add 13, add 13, add 13, add 13, right? You guys kind of with me? That's how you set up your classes. Now, a histogram could look very different if somebody else chose a different number of classes, started at a different number. So generally, I want us to start at the first data point, but you could totally start at 5 here if you wanted to. You with me? But you gotta have a decent reason to do that, right? Or else somebody could accuse you of trying to manipulate what it looks like. Okay. All right. Now, something else we did last time was the stem and leaf plot. You guys remember that?
Mm-hmm.
How do you guys feel about stem and leaf plot? I mean, the correct answer should be, you love that shit. Because, and again, I don't want to make you feel bad if it confuses you, but it really isn't terrible. So, what I want to do, I've got kind of a review sheet. It has some stem and leaf stuff, and then it has a histogram that's already been created that I just have a few questions about. And then the back is an example histogram that I kind of want to work with you on it. So just do 1, 2, 3 for right now. And feel free to work with people near you if you want to. Say again? Oh yeah, if you want to, it's up to you. If you want to turn around and get them many, if you just want to work with a couple people near you, that's fine. Just do 1, 2, 3 for right now. All right, guys, let's take a look. Let's do some unit line. Oh, scheisse. Where are you? There.
Yes.
All right, I think this first one should be okay. One big thing is you have to represent all the numbers. You have to put a 2 even though there's no 20s, because you have to show empty. That's information. There was nobody in their 20s.
If you don't, will you mark down?
Yes. So many. And then after the 1, so this is sort of, you don't have to put this in order. There's nothing about stem and leaf that says it must be in order, but you might as well. So like 2, 3, 6, right? What'd you guys get for 20s? There was no 20s, Jeff. 3 30s?
1, 2, 2, 3, 5, 7, 8.
2, 2, 3, 5, 7, 8. I like that. 40s.
1, 1, 5, 6,
Do joy.
0, 2.
0, 2, okay. And then one nice thing when I ask you, just count and make sure you caught everybody, right? If you do this and you miss somebody and then there's later work, you'll only lose points once, right? So I grade conceptually, so I don't grade just is it right or wrong. You give partial credit. So that's why it's a good idea to show work. What am I still missing? Why is this not complete?
The key.
The key. Key master. So then, very often you just use the very first one, but you can use any of them. 1, 2 represents 12. I like it. So I only have to give 1, and then I know how to read all of them. It just is a template for how to read all of them. Quick question. Don't even write this, just think about this. What if I had 104? What would change? What would have to be added?
So you have to go all the way down.
6, 7, 8, 9, 10. I have a bunch of empties, right? 6, 7, 8, 9, 10. And then next to 10, I would have 4. That's crazy, right? That still means, so what does this mean? This really means 3 10s and a 1, 31, right? So this means 10 10s and a 4, 104. Bam. It follows the key. Chicken Z has. That wasn't there, so. Yeah. So number two, the only thing that would have to change if the data was actually, instead of 52 at 5.2, so forth, what's the only thing? The key. So now the key would be 1 line 2 means, now I know how to read the whole thing. What if there was 100, 520, 130? Well, the key would become 120. Now I know how to read the whole thing. Are you guys with me?
Yeah.
So this kind of display only works if I have a bunch of numbers that are sort of really kind of close to each other. They all have to have something similar. These are all 50, 60, 70, they're all some kind of T's, right? 10, 20, 30, 40. It wouldn't work if it was 50, 538, 7,947. There's no quick way to define all of those. Does that make sense? The key has to be something that applies to everything in it. So if I have numbers that are like very small and very big, stem and leaf is not a good way to represent it. I don't know if that makes sense to you guys. Oh, you never make sense to each other. Okay. Okay. Number 3 is confusing, and I understand because it's number 4 where we actually have to do work. Number 3, the work has all been done. Somebody's already done all the work. So the very first one is very often troubling or tricky. So I often ask people, how many people did it last 0 to 20 weeks? And they quickly tell me 11. 11 people. So then I just say, how many total people are in there? 20. No work to do because the work's already been done. Did I turn that phone on? Is that recording?
Yeah, it's on.
Thanks, man. And then this also gets people, because I'll often have people tell me there's 4 classes, but I say, how many empty classes are there? 2 of them, right? 2 empty classes?
Mm-hmm.
So how many total classes are there? 6. And how wide is each class? We'll just pick a class and see how wide it is. 20. Now let's check the work. I'm going to do something extra. This is not something we have to do because it's already something they did. What's the highest minus the lowest? Right? High minus low, the class width thing. High minus low. 120 minus 0, 120. Divided by 6 classes. What's 120 divided by 6? 20. That's the width. That's exactly what they used. That's why they used it. Oh. So,
How would you know it's 0 and not 20?
excellent question. I was about to say something about that, but I didn't know if I should. Do I know that there are any 120? Anybody said 120? Do we know if anybody said 120?
No.
All we know is 2 people said somewhere between 100 and 120, right? I like it. That's why it was kind of a push to do that, but we don't have the data. We just have their histogram. Yeah. Okay, maybe. So did anybody say 0? That would be very strange. That would mean they get home and they dump it all on the head. They must have like really long hair. I don't know. They get a lot of people to come in and help them. They do the hair in sections. They pass the bottle down. Or not. Okay. Yeah. I'm sorry. I will say this real quick. I am trying to, I've done a pretty good job, but I keep forgetting to change this one. I'm trying to get rid of all my gender-specific questions, but I should have said maybe long-haired and short-haired people, right? Because for me, very often, I kind of go in this direction, right? They last me forever, because I don't really have to use much. But for anybody who's got much longer, and when I was 16, I had hair down to here. I have no idea how I stood that, because I can't stand messing with my hair. Just freaking keep it going. Anyway. So what percentage does the bottle of shampoo last at least 40? Can somebody tell me how many people said at least 40 weeks?
2. No.
3.
So at least 40 means 40 or more, and I only see 3 total, right? You see that? At least 40 means 40 or more.
Oh.
So I see 3 people. So I always keep in mind, we are going to see the words at least and at most in here, especially when we do probability. I think of at least being, you have to be at least this tall to ride the ride. You with me?
Yep.
You guys ever seen that kind of sign?
Can I have the handout?
Oh yeah. So I think of that, you have to be at least this tall means you have to be that tall or more, right? So at least means that or more. What if you have to be at most 12 to eat off the kids menu at some restaurant? Can you eat off that kid's menu for 13?
Yeah.
No.
You just lied.
What happened? Oh, sure, yeah, but technically, can you say your true age and eat off the kid's menu if you're 13? No. Can you lie if you look like a young 15? Hell yeah. Could I lie? No, I couldn't. I'm 12. Get out of here. All right. You need help, sir. All right. How about senior citizen? Maybe. Don't say that. So 3 people, but I want a percentage. So 3 people out of 20 people. I like it, which is 15 over 100, which is 15%. Big ass. Is that cool? Okay. So sometimes when I want a percentage of something, the very first step is just what's the number, and then divide by the total. So that's kind of like relative frequency. That's why that's the same as percentage. Big ass. Okay. So looking at this then, let's do this. I don't have a lot of calculators, so first come, first serve. Let's see. If you want to borrow a calculator, I need a photo ID or something even more precious like a phone or something. Bring it up and get yourself a calculator. Oh, did I? Shoot, I forgot to bring it out.
No.
This one should make it.
Well, they were cheaper than the first.
These are all good batteries. Don't be too far away. Check the batteries. Well, should be good. Yeah. So make sure those batteries are okay. One more. Uno mas. Yes. Okay, that's it. Okay. So one of the most basic things we can do. Oh, I can use this one since I got one left. No, I don't. Oh. Give me a second. I gotta wake up the emulator on my computer.
Is it better to just use the emulator?
What do you mean? Remarkably enough, you're not allowed to use a computer on the test.
Oh,
Yeah, you want to get that calculator if you can. But yeah, in general, if we had enough computer labs, we would teach statistics on Excel in a computer lab. Because Excel would be like a generally good skill. But we don't, so we don't. All right, hold on, sorry. Yeah, there, clear. Big. Okay. All right, guys, so a couple of quick questions. Besides the on button, just to preempt my smartasses, what looks to be the most important key on here? Huh? Stat, holy shit, yeah.
on.
I already said besides.
Oh, sorry.
Okay, I appreciate that. Yes.
Second?
Second's important,
Equals.
but like you said, stat, right? There's a stat button. There's also a freaking math button, right? That seems like there'd be a ton in there, but we're not gonna go there right now. So let's hit the stat button. Actually, wait a minute. How many guys have never really used, I asked this in the survey, and I think there's just a few, but how many guys have never really used a TI calculator before? Okay, a few of you guys. Okay, that looks to be about what I was expecting. Notice a couple of things about this. If you put, everybody do this with me, 9 minus 7 divided by 11. Bam, right? And you get some ugly little number. Poor little number, I'm sorry. Let's say I wanted to do the square root of that number. You can save a little time. One of the best little keys to use is the A and S key. It's right above the negative button. And by the way, do you notice there's 2 negative buttons, sort of? There's a negative and there's a minus. And that's what they mean. If you use it at the wrong time, things will go bad. So if I want to take the square root of this, where's the square root button? right above the square. So I hit second square to get the square root, and then hit second negative to get answer. So that answer means it has the last number I saw on the screen. It's a memory location. You guys kind of with me? So if I do square root of answer, it's going to take the square root of the last thing on the screen. I don't have to write all those silly decimals down. So let's see if we get the same answer.
Where's the answer?
Yay. You guys sort of with me?
Where did the answer button come from?
Right above the negative button, the very bottom.
Oh, okay.
Colors correspond to the second count.
Say again, sorry.
I was saying the colors correspond to the second count.
Yes. Oh, yeah, exactly. All right, and let's say I wanted to, I don't know, subtract 11 from that. Everybody just hit the minus button and see what the calculator does. It assumes you mean subtract something from the last number on the screen, so it puts the answer right there for you. Do you guys see that? So then minus 11. Wow. Okay. You guys all with me? Do notice that this calculator shows the entire thing you're putting in. The calculator knows order operations. Please excuse my dumbass son. Or dear Aunt Sally, or deficient algebra skills, or whatever. You guys with me? So if you put something in incorrectly, garbage in, garbage out, it knows order operations. You have to be careful how you put stuff in. So we'll do some more with this when we get some bigger equations where things get a little bit harder to put in, right? One of the biggest things though is if I have a fraction with a lot of stuff over a lot of stuff, I have to put parentheses around the top, parentheses around the bottom, because thank God the calculator has no eyeballs. That would be weird, right? Just pointed at something. So if I had, for example, I'd have to put in there, if I had 4 minus 6 divided by 8 minus 35. Right, so that'll be -2 divided by -27, and it'll do that. So if you don't put the parentheses, it's only going to divide the 6 and the 8, because it knows order of operations. Do you guys kind of follow what I'm saying? So you have to be careful how you put stuff in. Okay, I like it. And if I ask you, like, what's the average age, and you do stuff and you get a negative number, you should know, okay, I put something in there wrong. Okay. All right. So let's hit the stat button and see what's up. So I get a very unsatisfactory, boring looking list. Notice the second and third things. That obviously is where I can have it sort stuff, right? What's the difference between the second and third thing? Yeah, good. Ascending, descending. So most of the time we're going to go small to big, so we're going to use number 2. It's not going to be able to sort shit until I actually give it something to sort, correct? So let's do this. One of the places you're going to be going to a lot is going to be edit. So everybody hit edit. Enter. Just hit the enter button for this. Bam! Now, does anybody have stuff in their lists? A few of you guys. Is anyone missing a list? Like, is list 2 gone or something? No? Okay. So let me do both of these. So if you have stuff in your list, I just put some stuff in my list. Okay. If you go up to it, if you hit delete, delete's going to suck, because then it's just going to make list 1 go away. And that sucks a little more than you know right now. There's certain things that defaults to list 1. If it's gone, you're oh well. So how do I resurrect it, right? Well, I need a gem worth 500 gold. No. I need to hit stat, setup editor. If there's ever, you could borrow somebody's calculator, and the list could be called Frank, Joe, Billy, Bob. They could rename the list, they could kill a list, they could do all kinds of shit. If you want to make it back to normal, hit setup editor. Just hit number 5 here, and then enter. Very anticlimactic. Go back in, list 1's back. If you want to clear a list, actually clear it. So you see how I went up to list 1? Then I can hit clear. No. You guys with me?
Yeah.
Okay. So everybody's got a screen that looks like this now, right?
Mm-hmm.
So take a minute and put the data that's in this problem. The father's heights data. That data is actually from you guys. Well, from both my stats classes, so I just randomly picked 30 answers to that question and put them up here. So I'll start doing that also.
You have 2 stats classes?
I do. So by the way, I keep forgetting, I need to tell my other stats classes. My other stats class meets at 12:30 on the other side of campus. So if you ever are like, I'm gonna miss, but I could go to the other one, just tell me ahead of time.
And
Yes.
it's the same?
That has a lot of people in it, so I can't like have 10 of you suddenly show up there, if you understand what I'm saying. And you can't suddenly start going to that one, because you don't belong to that one. But if there's a day, you're like, I got shit to do, but I'm free at 12:30, I can go to the other class, let me know, so I can make sure there's room, and then you come out there, you with me? I'll tell you what room it is. Right now I forgot, because I had to change the room so many times to find an AC that works out there in the trailers. It's really bad out there. Sorry, keep going. I can't see where shit was. Let me put it up here. That's not gonna help, John. I'm gonna do this for a minute.
What do you do when you're done?
You sit there and you contemplate life. Or, sorry. Hang out for a second, let me catch up with you, I'm sorry. Hello.
I used to, now I teach one house, but I'm probably in.
Okay. Alright, one thing, thank God, you notice how the last thing I put in is in the 35th position, which is really good to see because it's 35 data points. What sucks is you got like so many data points and you have one you're missing. Oh crap, what did I miss? I'm gonna double check here real quick.
Is there a quick way to go from 1 to 35?
Yeah, if you go up to list one and hit the up arrow, I think it should.
No, how to go from all the way from the last value to the first value?
Then you hit down from the last value. Right, did that work?
Yeah.
Okay. It's sort of like Pac-Man where you go off the screen, come on the other side.
Oh, love it.
Alright guys, so since we're going to create a histogram, I'm gonna want my data in order. That'll make it quicker to count the frequency for the classes we're gonna set up, correct? So the first thing you do with data is put it in order. So how did we say we're gonna do that? Where was that?
Stat,
Stat,
sort A.
sort A, I love it. Now notice how that looks like a function. Remember functions have the parenthesis? So I wanna do that to something. I wanna do that to list one.
Oh, 1.
Do you look above number 1? Do you see where it says list 1? So you hit second 1 to tell it list 1.
You don't need the parentheses.
I know it's not David Blaine level shit, but it's still, you know, it's nifty. Now if you go back in, see it's very anticlimactic, but if you go back in stat edit, now it's all in order,
Oh, cool.
right? And it costs enough money, you should be able to do that, right?
Yeah.
Alright. Yes.
I have a different calculator, I don't know how to get to my stat function.
Alright, part of me wants to say good luck. So you should have, let's see, graph, calc, test. It has a little arrow key. Screen, stat. Yeah, I don't think that's gonna be it. Yeah, I don't know, dude, sorry. You'd have to look up the manual for it. Then you tell it which list. So see how above the 1 it says list 1? So hit second 1, so you tell it which list to sort.
And then just enter?
Enter. And it feels like it didn't do anything, but now you go back to edit. Yes? Sorry. Yeah.
Yeah.
I already had it in order because.
No.
It's second mode, out of the way. Now go to
So it's trying to get like this.
second mode. Then go to stat, edit. Edit, yeah. So it's not as order yet, right? Stat, sort. And then second one. What you forgot about that? Now go back to stat, edit.
That's why.
Oh, L1 is above 1, so the second one. Oh, it's not gonna like that. So now go stat, edit. Everybody doing all right? So trust me, technology days are always freaky, because if you're borrowing your calculator, who knows what the person did before you? You get all kinds of weird error messages and such, yes.
I have one of those, I just can't find the card for it.
Gotcha. There's very few other calculators that I know how to use. Because, to be honest, if I ever have to do actual statistics, I'm gonna use Excel. Yeah, but I know how to use the TI because it teaches us. All right, guys. Shit. Okay. Let's go back to Moodline. So help me, now that we got this sorted, we're ready for once we have classes set up. Somebody help me out with the list right there. What's the highest number? 77. And the lowest number? 60. And I tell you on this problem to use 5 classes, right? So on a quiz or a test, I might not. You just have to use 5 or 6. So if we use 5,
3.4.
good. 3.4. Whenever you get any decimal, you round up. Make it easier on ourselves. Right?
No.
So our width is going to be 4. So what number should I start the first class at?
60.
Yeah, because that's the first data point, 60. So where's the next class going to start?
64.
4, because you have to have a width of 4, correct? Does that make sense? This can't also be 64, else I wouldn't know where to put 64, so it must be 63. Now, if you find that to be unsatisfactory, because 63 minus 60 is 3, not 4, count 60, 61, 62, 63. No, right? No? What about this? Remember you have to do down 0.5, up 0.5? Remember that?
Yeah.
Okay. So you have to go to 59.5 to 63.5. That's 4. So the class width is hidden when you do it this way. Remember I showed you the other way with the inequalities? Mm-hmm. If you want to do it that way, things are a little more explicit, but you just have to be comfortable with inequalities in X, right? So it's up to you. I'm always going to do it this way because that's the way the book does it. But if you want to do it the inequality method, you'll have an easier time with a few things. So again, just to show you, well, let's finish this out and then I'll show you what the classes will look like if it did the inequality method. Now I just keep adding 4 until I go crazy. Or until I get to the end here. Alright. So there's my 5 classes, right? So if I did it the inequality method, this first class would look like this. The second class would look like this. Then you can see the width both this way and that way. And when I go to make my histogram, I don't have to go up and down by 0.5. But the trade-off is you have to be comfortable with inequality notation, right? So it's up to you. You can choose either way. Yes?
What do you have on the edge there? Is it 63 or 64? 64, okay.
Yeah. Which class does 64 go into?
The next one.
The second one, because that's where it's allowed to equal 64. This is less than 64. I like it. If you don't like this, okay, don't do it. Do this. So how frequently did something show up between 60 and 63? No? Twice. There's 60 and 62, correct? I see 60 and I see 62 in my data. There's 2 data points. You guys with me? What about 64 to 67? Look at the data, count how many data points?
7.
What about 68 to 71?
15.
15. Right, you can double check that. 72 to 75?
9.
9. And then 76 to 79? 2. Now, before I go any further, I think I mentioned this before, bell curve, right? I mentioned the bell curve. You guys all know what the bell curve is. It's also called a normal distribution. The reason it's called the normal distribution is height is something I expect to follow a normal distribution because heights normally fall between two certain values. And very infrequently would we get people that are really tall or really short. The bulk of them are going to be in the middle. Are you guys with me? So if I'm looking at heights, I have a few people here, most people in here, and then a few people out there. Is that what that does? Does it start low, go high, go low?
Yep.
Starts at 2, goes to 15, goes back down to 2. Is it perfectly normal? Perfectly normal would be symmetric.
No.
Is that symmetric? No. Is it loosely normal? Yes, totally. Are you guys with me? And you're all like, I'm loosely normal. Okay, I like that. What's another name for relative frequency? Percentage. It's just a percentage. So how many people from there? 2 out of what? 35. So what's 2 divided by 35?
How do you go to the normal calculator from this list?
Oh, I love it. Anytime you're in a weird place, hit second mode.
Oh.
See, it says quit. It'll always bring you back to what I call the home screen. Second mode, that's quit.
5.7.
Sorry? 5.7%, yeah.
Where'd you get 35?
How many total people are there?
Oh.
So there's 2 people in this class out of 35 total people, percentage. Well, 7 divided by 35 is nice, because that's 1/5, 20%. 15 divided by 35,
42.8.
42.85, so it's like 9. 9, what's that? What is it?
25.7.
25.7? And then 2 out of 35 we know already. Alright. Alright, it's blurry. There it is. Somebody with that. If I add these all up, it better be close to 5%. Or 1, as a decimal, yeah. Now, these are, let's see, these look like they will. Wait, 1, 2, 3. Yeah, it looks like it should. So double check. Yes.
So it should add up to 100, but like, say you're off by a little bit, like what's the margin of error there you have?
It's roughly 99.5 to 100.5. If you add them up and you get 101, no. Or you get 99, or if you get 95%, hell no. You left out 5% of the data somewhere, right?
Like 0.5.
So like 0.5 up and down is nothing to be worried about. That's normal for rounding errors. And it can be further off the more data points I have, but that's kind of a normal gauge. Now there was a few people that had questions about this. This shows up in the book. All this means is you accumulate frequency as you go down. So when I'm coming, I'm not even gonna look at the problem yet. I've got 0% so far. Then I go down to this class. How much percent do I have total?
5.7.
5.7. Then I go to the next one and I add that. I accumulate as I go. So now I got 25.7. Then I add this and I get 68.6. Is that right?
Yeah.
And then I add this and I get
4.3.
94.3. Is that right? And then add this and I get 100. Woo! So when I do cumulative frequency, this last one should be close to 100%. Okay. Yes.
When you do the real freak, do you want that percentage, or is it okay to put the decimal?
Decimal's fine. Percentage is just generally better. Because percentages are something we, now of course, humans made up every damn thing. We made up the symbol for the number 2, for example. But percentages are another level of made up. 0.45 is the actual number, 45% is a number that's rounder that humans can relate to better. Does that make sense? So technically you don't have to, the percentages are preferred. I've heard that humans prefer them. So for this guy, considering we did it this way, yeah, sorry?
Sorry, for the cumulative, does it always have to equal 100, or you said close to?
Well, again, if there's some rounding, it could be off. But it should be within 99.5 to 100.5. If it's more or less than that, then that's an issue. You might have left something out, or, yeah. So everybody doing okay? If I add them up, I get 107%. I just created people, right? Which humans can do, but normally not that quick. Yes?
So in the homework you said you would put okay or not okay, right?
Sure.
So in
Well, I put okay, which means you could have made some mistakes, but nothing major, so you should look through it. I put correct, meaning you have half credit, and you can make corrections, and they're due by the day of the final, and you get back up to full credit. I'll say redo, which means you got no credit, but you can get full credit if you redo the problems you got wrong and get enough of them right? Or I'll say no credit, which means you've cheated and blah, blah, blah. Okay. I appreciate stats, though. It's harder to cheat in stats because you can't just point your photomath app at it. If anyone knows what I'm talking about. Do you guys know about photomath? So do us. So do we. So do math teachers. And photomath does things in a weird ass way. So I love it when I ask somebody, "What did you do there?" Well, I just tried to get out of here. Tried it. Sorry. All right. Sorry. So what am I gonna have to put down here? I can't put 60. Remind me. What do I put?
6.
I've got to go
Oh,
down
0.
by a half, right? So I put 59.5, right? And then the width is 4, so I just keep going up by 4. This is the trade-off for doing it this way. Okay. Now, this axis, how far up do I need to go? What kind of histogram am I making?
50.
Relative frequency. Relative frequency. So how high do I need the scale to go?
40%.
Yeah, maybe 45%, right? So that I have a place for this to live. You almost never take this to 100%. If you take this to 100%, your picture is going to look like this, which is not very easy to see. Grow that thing, use some space. So let me go up to 45, maybe I'll go 5, 10, 15, 20, 25, 38, 35, 48, 45. My scale sucks, I don't care. Real freak, so label that, right? You gotta put labels. And then this, father's heights. Inches. Label, label, label. There's that one problem in section 1.4 where they didn't label a damn thing. And that sucks, it's bad. Okay?
You can put RF for real free.
Real freak RF, I love it. How tall is that first bar gonna be?
About 6.
About 6, right? So first bar is gonna go up to almost 6, so it's gonna be just above 5. You guys with me now? It's the easy step, right?
Yeah.
The next bar should go up to 20. The next bar should go up to 43 roughly. And then 25.7. And then 60. So I get this, so. Sorry. So it does sort of look like it's flipping us off. And so when you're using 5 classes, if it's gonna be roughly bell-shaped, it will look like somebody flipping us the bird. So that's, do you not agree? Is that what that looks like? No? It's just me? Okay. So it starts low, goes high, goes low. It's not symmetric, but it's roughly normal. Is that pretty good?
Yeah.
So this is the kind of problem that's gonna be on that second quiz, right? In case you didn't see this, 2 quizzes, one next Wednesday, one following Wednesday. this Wednesday as quiz 1. Okay. Any questions on that? This is just a review of what we did last time. So, let's do this. Oh, geez. Let me ask you guys this. Have any of you taken the SAT test? Anytime? A few of you guys? When they give you the scores, I am not asking for your score. When they give you the score, do they not report it as a percentile? You guys remember? Yes, so a few of you, okay. Understood. Mine was, I think I beat you, okay? The last time I took the SAT. So what the hell is a percentile? So has anyone ever heard that word before, percentile?
Yes.
You're in the 80th percentile height. So when you're a little kid, or if you have any kids, you always talk about the height and the weight. You have the height and the weight chart. So your kid could be in the 90th percentile height and the 20th percentile weight. That means they're really tall and they're skinny as hell. Yes? Yes?
Is that like when you have your manicure?
Yeah, totally. We're getting there. I love it. Kick ass. So if I'm in the 90th, if I'm 4 years old, I'm in the 90th percentile height for 4-year-olds. What do you think that means? I am taller than 90% of every other 4-year-old, at least in the States. Normally it's by country. Are you guys all with me? Okay. Okay. Percentiles never mean anything except that. If the 11th percentile on a test is 30, that means 11% of the people scored less than a 30, right? You guys with me? Will a higher percentile always be good? On a test, will it be good? Yes. Playing golf. Anybody play golf? Does everybody realize what do you want for golf? A high score or a low score? So is a high percentile in golf, is that good? No. Okay. The interpretation of a percentile depends on what the situation is. Test, you want high. Golf, you want low. Cost of a home, you want low. Selling price of a home, you want high. I mean, you guys see what I'm saying? So, but percentiles never mean anything other than this percentage is less than that number, right? You guys with me? So if the 80th percentile time to finish a race is 10 minutes, what does that mean?
About 80% of people can finish in 10 minutes.
Or less. So 80% of people took less than 10 minutes to finish. So percentiles is always that percent below. You guys follow? Okay. So that's the idea. Now let's kind of try to figure out the math behind this. Is it better? I don't know which way it's better. Keep it here. Let's see. The most exciting part of class is watching Jeff do this. Okay. All right. I want you guys to go away. Now, I'm going to write 10 numbers up here. And I want somebody to tell me their guess for what the 80th percentile might be. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You guys see that? That blue marker's kind of on its last legs. Does anyone have a guess as to what the 80th percentile, let's say these are ages of people. Ages of people somewhere, right? Very specific problem. Anybody have a guess for what the 80th percentile would be? I'm not grading this.
30?
All right, so I got a guess for 30. Why did you say 30?
Because it's kind of like not at the top, not at the
Oh,
bottom.
okay. So that's your general kind of like get a feel for it. It's going to be up towards the top. Because shouldn't the 80th percentile be like past 80% of the data? So it's definitely going to be on that side, not that side. 11. Anyone have a more specific guess? Yes.
31.
All right, why do you say 31?
Because it's number 8. The 10 numbers.
Oh, it's the 8th number. Okay. Yes.
Like
like 25?
25. Why would you say 25?
Cause like, isn't it like, 80% of the people are like 25 or older?
So percentiles are like that percent below.
Okay.
But doesn't this more cut this almost in half? I want 80% to be below this number. So you see why we're focusing more on that side?
Okay.
Yes. Why would you say 32? It's not even up there, right? So you're just saying 32 what? Okay. So isn't the 80th percentile number supposed to have 80% of the data below it?
Yeah.
So nobody's given me the number that's got that, because how many numbers are below 33? 8. So that would be a good guess for the 80th percentile, because it's got 80% of the numbers below it. Shouldn't the 80th percentile also have 20% above it, though?
Yeah.
How many numbers are above 33? 1. So 10% is above that, so that doesn't work. This one works for 20% above, but it does not work for 80% below, right? So a little bit 32 right there. That's exactly right. 32, how many numbers are above 32? 2 out of 10, 20%. How many numbers are below 32? 8 out of 10, 80%. Kick ass. You guys, okay. Do you understand why we actually had to average 2 numbers? No. I really want this to make sense. 80, what's 80% of 10? 8. So the 80th percentile has to have 2 things. It has to have 8 numbers below it. 33 has 8 numbers below it. Yes? Doesn't 33 have 8 numbers below it?
Yeah.
It has to have 2 numbers above it, because it's got to have 20% above it. 31 has 2 numbers above. Yes? So is there any actual data point that has 8 below and 2 above at the same time? No. So what do we have to do? We have to split the difference between those 2. Those 2 each satisfy 1 requirement. If I split the difference, I'm golden. Yes? Maybe? Okay. I want this to make a little bit, tiny bit of sense. Okay. So 32. So the symbol for the 80th percentile, because math people don't like to write, in my case it's because I can't write, is P80. It's not a new fitness craze. It's capital P with a little number underneath, that's a percentile, right? So P80 in this case is 32. Okay. So sometimes I'm going to have to average 2 numbers to figure out the answer. So let's try this. Let's kind of break down what the work would be for P80. There's going to be 2 steps for every percentile. Does this make sense? The 80th percentile should be a number that is about 80% of the way into the list. So an excellent first step is what you guys sort of did, either kind of like by feel or you actually literally did it. What is 80% of 10? That's your first step. 80% of 10. How do you do this in the calculator, by the way? 80% of 10. What would you put in the calculator? 0.8. 0.8, good. 0.8. What does of mean? Times 10, good. So you get 8. So there's only 2 things that can happen when you're calculating a percentile. Either you get a whole number on the first step, or you get some decimal number. If you get a whole number, that means average that one with the next one. Isn't that what we did here? 80% of 10 is 8. So take the 8th and the 9th numbers and average them. Maybe? No. Okay. Do you guys, are you following? Okay, okay. So if I average the 8th and 9th numbers, I get 32. So let me ask you, if I have 4 numbers, let's say they're 1, 2, 3, 4, what number is right in the middle? Didn't you average 2 and 3? Isn't right in the middle, isn't that P50? Okay, so we're just extending that idea to every percentile. P80, same thing's going to happen. I'm going to sometimes be in between 2 possible values, right? Yes?
So if your answer is 8, Why is it the average of 8 and 9, not the average of 7 and 8?
Because it's at least the 8th number. So you average that with the next one up. Yeah. Okay. And again, it kind of makes sense. The 8th number has 2 above it, so it makes sense. The 9th number has 8 below it, so it makes sense. So of course those should be the 2 that you average to get the actual answer. The one that makes both things happen. Are you guys kind of with me? So anytime you do this first step, the first step is where is the answer? The second step is go get the answer. Anytime you do this first step and you get a whole number, you average that with the next one. So real quick, let's do this. What's P50? So what's the first step? 50% of? Why do we keep doing 10, by the way? Is it always going to be 10?
No.
Why is it 10 here? Because there's 10 freaking numbers. So if I have 38 numbers, don't do 10, right? Do 38, right? What is 50% of 10? Half of 10? 5. What does that mean? Average the 5th and the 6th. So 1, 2, 3, 4, 5, 6. What do I get when I average these two? 27.5. Isn't that the number in the middle? Doesn't that have 5 below it, 5 above it? So it is the number in the middle. Okay. Which is what P50 should be. The number in the middle. Kick ass. All right, let me stop for a minute. All right, let me continue. What about P37? Do that. I'll wait. We'll do the first step. Because I haven't told you what to do yet for this. The beautiful thing is when you multiply by 10, you just move the decimal over once. So 0.37 times 10, 3.7. If you get anything that's not a whole number, you round up. So the 4th number is the answer. 1, 2, 3, 4. Can anybody tell me what P38 would be without doing any work?
Same.
The same damn thing. Why is that okay? Well, how many data points do we have? 10. We only have 10. So I can't be this granular. There's not going to be a different answer for P37, P38 because I only have 10 data points. If I had 1,000 data points, then P37 and P38 could be the different because I have a lot of data points to choose from, right? You guys kind of follow. Okay. The rest of you guys are like, no, I don't follow you ever. Okay. So if I had 857 data points, I'm not going to write them down, and I want to know what P63 is. What would you do? 63% of 857. Whatever the shit that is, help me out. 539.91. So you got. Is that a whole number? Nope. So I'm going to round up. So what would be the answer? Is the answer 540? No, the answer would be the 540th number. That would be the answer. I didn't give us the number, so whatever the 540th number is, that's the answer. I really want this to make sense. If the percentile means that percentage is below it, then of course I want to go that percent of the way into the list because I left that percentage below me. That makes sense. That's a good first step. And the second step is just an adjustment. All right, if I got a whole number, I got to do something. If I got a decimal, I got to do something just to be more specific when I get there. Right? Yeah.
So for the 37 percentile, you got 20. Why wouldn't you get the average between the 4th and the 5th number?
Because we only do that if I get to 4.
With like P80, you
I got a whole number answer, right? P80 was 8. If I got a whole number answer, I average that with the next. If I get anything else, I round up and take that number. Yeah. And why does it make sense? If I have 5 numbers, what should the middle number be? The third number. But what's half of 5?
2.5.
All right, so you got to round up to 3 to make it make sense. It should be the third number, right? So if you get a decimal for the first step, you round up and you take that number. If you get a whole number, you average that with the next one. That's the 2 things that could happen to you with percentiles. Kick ass. Now, there are some percentiles that should have different names. For example, P25. Thank you. If I am, even if you don't watch football or basketball, whatever, soccer only has halves, that's right. If I'm watching a basketball game or a football game, and it's 25% of the way through, P25, that is the end of the, so another name for P25 is Q1. Ooh. So, of course I erased the data, damn it. Yeah, it's still there. Everybody's got this data, right? Thank you. What is it, 16?
20, 27.
Okay. So, real quick, what's the lowest data point? 11. Figure out what Q1 is. Figure out what Q2 is. Right? Go ahead. I'll wait. Oh yeah. By the way, we are going to do at least one more statistical thing with the calculator, so just hang on those.
So would Q2 be,
P50, right? 2 quarters, 50 cents, 50th percentile. 3 quarters, 75 cents, 75th percentile. So Q1, how would I do that? 25% of
10.
10, 2.5, third number,
16.
16. Q2 is P50, so 50% of 10. Did we do that one?
Yeah.
We did that earlier. We got 27.5, right? 50% of 10 is 5, so average the 50 to 6, and we get 27.5. We did that a second ago, or several seconds. Now let me show you a little shortcut for Q3. Q3, you do 75%, blah, blah, blah. For Q1, didn't have to go 3 in from the bottom? Shouldn't Q3 be symmetric on the other side?
Yeah.
Q1 is 25% of the way in from the bottom. Q3 is still 25% of the way in from the top. So if I just count 3 from the top, 31, done. Or, let's see, so it should be 31, right? What's 75% of 10? 7.5, rounded to 8. What's the 8th number? 31, okay. So you got a little shortcut for Q3. Shortcuts are very often unnecessary, but you know, they save a little bit of time. And then what's the highest number? 51? Yeah. So doesn't this look like, good Lord. You guys get drunk, Jeff, because man, it's been a long day. Doesn't this look like a game? The beginning of the game, first quarter, second quarter, third quarter, end. There's 5 numbers. So math people being very creative, we call this the 5-number summary. Go us, right? Like 5 numbers to summarize, hey. From this, have you guys ever seen a picture that looks like this? Representing data? It's called a box plot. It's actually called a box and whisker plot, which is more interesting. See the box in the middle? See the whiskers on the side? Okay, so we're going to construct that from this data. So I want to go from 11, so let me start at 10, and I got to go up to 51. So let me go by 10, 10, 20, 30, 40, 50, 60, okay. Let me go by 5, so no, 15, 25, 30. Okay. So here's what we're gonna do. We're gonna be different from algebra, because statistics has to be, right? So instead of putting the little points on the line, I'm gonna put a line above the one. So what I mean by that, put a line above 11 like this. Put a line above 16, put a line above 27.5 roughly, put a line above 31, and a line above 51. Looks like a bunch of nothing. Take the middle 3 and box it off, and then draw your whiskers. Let me ask you a key question here. What's in the box? What's in the box? Can anybody tell me what percentage of the data is in the box? What percentage of the data is in the box? What did this line mean? Where did this line come from? What was that line?
Oh, 50%.
What was that line? Q3. 75% below it, correct? Yes? What was this line? 25% below it, correct? So what percentage is in the box? 50. So the box always represents the middle 50%. Is anybody considering transferring after their stint here at Grossmont? You gonna transfer to university, different college, anybody? A few of you guys. Anybody still trying to decide which university or college to go to? A few of you guys, okay. There are these books you can get. One of them is called the Princeton Review of Colleges and whatever, okay. If you open that sucker, for every college, they say the middle 50% of SAT scores, the middle 50%, blah, blah, blah. So they're saying sort of like ignoring the extremes, what does the heart of the student body look like? And then you have people that didn't do quite so well and people that did way better, right? But the middle 50% is the heartland, right, of the data. Okay, maybe? That's one place you'll see it. Also, what if this was scores on a 60-question quiz? You with me? Good Lord, 60-question test, let's say, right? So number of problems you get right or whatever. You with me? What if another class looked like this? So same scale, right? 0, 10, blah, blah, blah. So they look like this. Oh, there's another color. What do you got, Jeff? There. But here's a hard question. Which class did better? Well, to me, it's not that hard. 75% of this class did better than 75% of this other class. Do you guys see that? So if you draw this, and it was relatively quick to get these, right? So if you draw this, it's a really quick way to compare two different sets of data. I can quickly see who's more spread out, which one did better, blah, blah, blah. Okay. You guys get that idea? Because you're about to do a problem like this. Yay. I've got a handout. So, I think was there any? No. Yeah, okay, perfect. On this handout, I want you to do number 2 first. This is the one with the box plots, right? With the visual of the box plots. And then we'll do number 1 after that. Let me give this poor guy a break. Part A should be very straightforward, right? How many total golf balls did I hit? Or did this person hit? 200. So my very first question is, looking at, what was it, Nike? No. Callaway. What percentage are below 252? 25%. 25%, because that's Q1, right? 25% of, no, 200. So that's the number. I must have had 50 golf balls that went that distance, below less than 252. Are you guys with me? Yeah. So if I know the percentiles, great. If I know the total number, I can actually figure out the amount in each area. Now, what happened? One thing that statistics tries to do is it tries to formalize ideas like, what's close, or what's unusual. So there's the idea of outliers. Outliers. So if I had a data that was 12, 14, 15, 78, the outlier is really obvious. Right? Were you with me? It's obviously 78's the outlier.
Yeah.
Because it doesn't follow the pattern of the other parts of the data. What if this was 38? Is that still an outlier?
Yeah.
Yeah.
Yeah. What if this was 28?
No.
See? So somewhere there's, if it's 18, are there any outliers? No. So there's a line somewhere, yes? There's a line somewhere. And it's very subjective. So one thing stats tries to do is it tries to come up with ways to objectify that, to actually make that something I can measure. So, okay, high minus low is called the what? Anybody remember? Starts with the R. Range. So there's something called the interquartile range. So it's a range, but it's the interquartile. So what I do is I go in one step. So Q3 minus Q1 is the interquartile range. We stop for a minute. So we define the interquartile range to be Q3 minus Q1. So one attempt that was made to define where outliers start, where the idea of unusual, wouldn't an outlier be something that's unusual? Unusually high, unusually low, yes? One definition of it was to do this. The minimum normal value would be start at Q1 and go down 1.5 IQRs. And of course it makes sense that the max would be start at Q3 and go up 1.5 IQRs. So this is just an attempt to formalize what unusual means. Where does unusual start? So for example, on our problem that we did here, what was the interquartile range? Q3 minus Q1, 31 minus 16, 15. Yes? So it's whatever Q3 is minus whatever Q1 is the interquartile range. Now if I take let's do this. Take Q3 plus 1.5 times 15. So take 31 plus 1.5 times 15. Somebody help me out with what that is. $1.5 times 15 is 22.5. So 31 plus 22.5 is 53.5. And I think the highest data point was 51. So are there any unusually large data points? No, there's nothing in the data that was above 53.5. This is where unusual would start. So in your data, the nice thing with number 2, you don't have to calculate the quartiles. They actually did it already, right? So you know what Q3 is and what Q1 is for the Nike data. You guys see what I'm saying? You can calculate the IQR. It's just Q3 minus Q1. All right, so go for it. Try out part B. Okay.